Kodak, where I'm the principal engineer. I've worked in all sorts of different industries, aviation, automotive, finance, all sorts of different cool places, and hopefully I can sort of give a bit of that experience here. I've worked principally mostly in sort of structured programming and object-oriented sort of programming environments, and so functional is fairly new to me, and I'd like to share my experience with adopting it, when I found out how cool it was, and some of the pitfalls that I fell into, and hopefully you won't do that. I'm not very long, so I'll have to rattle through. If I'm going too quick, tell me, and I'll try and slow down. So it is. So, a bit about me. I've already done that bit. So the next bit is some biases. I've just told you a bit about who I am, and obviously that cues into a little bit how I think about things. So first of all, I've got a bit of a platform bias. I've coded in all kinds of different languages and different platforms, but mostly I've done stuff on .NET. I've been in .NET sort of web environment for quite a while now. So C#, object-oriented, I know all about that. F# for functional, kind of that's where my best knowledge is for functional. So if there are differences or things in Java with Scala and Clojure and stuff like that, where I know, I might key in, but obviously there are holes in my knowledge there. Recency illusion, functional programming is fairly new to me. I haven't been doing it my whole life. I'm not an academic, I've never studied it. So a lot of my excitement about it and my buzz around it is due to that primacy and that recency, so there might be gaps in knowledge right there. Another one, I write really boring enterprise code, and always have written really boring enterprise code. I'm not an academic, I'm not an elite hacker, so hopefully the enterprise code I've written is pretty good, but that's where I've come and tackled all of those problems, so that's generally the sort of environment where I've had to tackle problems. And once again, finally, once burned, twice shy, some of the point of this talk, I guess, is some of the times when I've used functional programming, been really excited about it, built it into a project, and then kind of maybe wish I hadn't written the code that I did. Which I think maybe we've all done at times with any amount of code, but I certainly did. So let's jump into it. So let's begin with functional for the win. So what I'm going to do is I'm going to go through a few points of the reasons why I think it's really cool, and then I'm going to go through a few points where I think maybe I did the wrong thing, or why it's maybe not right all the time. So first of all, something I think that's super cool and a really good usage of functional programming, and that's data transformation. So if you've got data in one shape and you want to turn it into data in another shape, it's really good for that. So let's look at some code. So here I've got some code that I'm going to do some data transformation with. So this is, I'm going to be fairly quick on the syntax because I'd like to talk about things we don't have very long. But for those of you who aren't familiar with F#, which is what this is called a record type. It's kind of a very simple, lightweight object, which is just like a thing where you can hold named fields in. There are similar things in Clojure, I think def record, and I think Scala has got case classes, is that right? I haven't used Scala an awful lot, but I think that's kind of similar sort of ideas, these kind of lightweight things. So with this sort of lightweight bit of data, if we want to transform that data in F#, we'll do it with a function. So here we've got a transform function, so we're going to take an input, which is this data in one shape, and we're going to take a new value, and then we're going to use this cool piece of syntax here, which is this input with. So that takes our input value and then sets one of the fields to our new value. This is a cool bit of syntactic sugar. What's actually happening here, because pretty much everything in F# is immutable, is we're creating a new object with that shape, and it's the same shape as our input data. So we're kind of like these ideas of doing transformations, and there's lots of nice syntactic sugar, especially around things like records, for just holding kind of loose shapes of data, and that's really fun. So I might have to put the mic down because I need to type. Do I need to use this? Can I shout?
It is quite quiet at the back.
I'll shout. Can you guys hear me at the back if I shout?
Yeah.
Excellent. So if we build this code, build, succeeded, and another cool thing about F#, which if you've been using C# for a while, there's no REPL, like no way to quickly do things. F#'s got a very good one, So here we're going to load up this assembly into the REPL here, so we can sort of play with the code live. So we need to open that, IDinLondon.dt, spelled that right. And then we're going to transform some input data. So transform, we've got key equals, that's a string, so so we'll leave that as an empty string for now because why not? And we have value equals, let's call it 2. And then we want to change this value of 2 to the value of 3. And now we have a new object with the same key because we can transform that bit and the value that we set. So that's cool, that's super easy. This is really nice sort of syntax for being able to do that. And as you'll notice that being able to test this is super easy. Because it's immutable, we can make certain sort of assumptions about the data, and we know that we can sort of test equivalence via its structural nature. So here we've got an input and output, and then we're going to test our transform function. So if we call test, then we get true. So this result and this output are the same because they're structurally the same, which is super easy. So this means that using this functional approach, the data into the function, given the data into the function, we get some output. We can just test against these two expectations, and testing is super easy in this way. There's no weird side effects to worry about. So that's one thing that's super cool about functional languages. Let's not forget that. So the next thing that I think is super cool about functional languages, or one of the patterns I think is super cool about functional languages, and F# definitely, this is centralized exception handling. This is a pattern which is very useful for a number of reasons in an application. And I tried to look for something that was a bit more sort of academic and lofty and not just my own opinion saying I think it's better. And I found this CWE 209, which if we go to it says, I found some network, but what it says is, thou shalt never leak information about the nature of your application through errors. So this means if you throw an exception and the exception gets sent to your end user and it includes a stack trace, that's not very good because it means that that end user or some nefarious user to your application knows about like the internal workings of your app, and that's not great. But in this instance, I can't. That's a real web page. You can go to it in your own time. It's fine. So let's have a look how that works in actual code. And I'm going to introduce some more things for F# while we do it. So here we have a couple of new kinds of type, which are also fairly common in functional languages. They're called unions, discriminated unions, or single case unions. They're in Elm, which is called front-end functional language. I don't think they're in Scala. Somebody can stop me if I'm wrong. Jan, are they in Scala? They are in Scala. Okay, different, but similar idea. Okay, so similar ideas are in a lot of these sort of functional languages. So what we've got here is the first one. We've got this cause of a failure. We've got not implemented for now. That's the one kind of failure I suppose that we can have. And this next thing is a result. I've called it it's something to do with monads, but let's forget that. I don't want to get bogged down in that stuff. So what it is our application can have a result when it does something, and that result can either be a success, and the success will be a thing. So that A thing is like a generic, which says we're going to pass back something that we want, or it's going to be a failure, and that failure is going to be of the type of that first thing, that union. And that's all that our application is going to be able to do. So here we have some work that our application might want to do, which is update a thing, which is exactly what we were doing in our data transformation. So we use the same function, this transform function. So we're saying if the value is greater than 5, then we're throwing a failure that we've called not implemented. Otherwise, we're going to give a success, which is the work that we want to do. Does everybody get that? Murmurings of noddings of yes. And that's really cool for a couple of reasons. It means that our application can catch all these failures, carry them around. We're not throwing exceptions. I'm someone who particularly dislikes exceptions. I think they're kind of like a go-to, but seem to be okay. So if we want to do some work, let's pretend that this is our controller. If this was a web application, right? And let's pretend that our data transformation is a request, and what we want to transform that into is a response. It seems pretty logical. That's sort of how the web works. So here we've got our do work. We take our request. I've lied about what that is. I've just given some static value to DB value. So our response is going to be an update of that thing, which is that function we just called to transform. And then what we want to do with the response in this one single place, sort of in our application, is we want to see if it's a success. If it's a success, take that response and then like serialize it as JSON, send it back to the client, do whatever. If it's a failure, then in this one place, we want to handle that failure and handle it in a way that's sort of decent, centralized. We know things aren't getting lost. We know some information isn't being leaked to the user. And also, this is cool because this means we can do other things in this one place. Like we can do all of our localization. Maybe we're a business that works across the world, and all of our exception messages need to be in all the languages that we work around, and we don't want to have to go through our application sort of like. There's one thing which is extra cool about F# that I just want to show you that we can do here as well. Is because this is so built into the type system, we can get the compiler to do some work for us. So let's add another failure case, which is validation value greater than 5. Have I spelled that right? So we've got a new failure case now. So some other kind of error can be raised in our application. So if we go down and look at our function here, we can see that the compiler is giving us a little hint. It's saying incomplete matches on this expression. For example, the value validation greater than 5 may indicate case not covered. So we now know that like our code is trying to tell us, not at runtime, but our code is trying to tell us at compile time, that there is something that can go wrong in our application that we haven't dealt with. So if we add that case, validation, and validation error, we can see that now that thing's gone away. So that's super cool. So the way we could do that is, one, we had that cool monadic type to catch failures, carry failures through our application. Also, the type system is really, really, really terse. We can throw in cool types and get the compiler to do work for us. And that's super cool. So, next point. Removal of infrastructure. So, as I said, writing enterprise code, an awful lot of that is writing like glue between big other vendor libraries, or writing glue between things you want to do in your application, and not writing business code. And that's rubbish, right? We want to write business code because that's the stuff that makes us money, business money, but I guess that kind of makes us money as well. And so we want to get rid of that because it's a waste of time. So one of the things that principally happens in OO, happens a lot in Java, definitely happens in C#, dependency injection is the bane of my life. I hate it. Hands up, anyone here who here has used dependency injection in an object? Right. So a lot of people. Hands up, who here has seen a test fail because they forgot to register in the container something that should be used in the application? Everybody, the same hands went up, right? What an absolute waste of time. So functional programming, definitely F# has a response to this as well. Don't look at that. Close your eyes. So I'm going to introduce one more thing, yet another thing. So this is a class. F# is built in .NET, which means that all the things you have in C# you also have in F#. So you have classes, don't worry, they're all there, if you really like them. So here we have a class. Say you're talking to something, a piece of framework that gives you a class that represents a database connection. I don't know whether any of you have used a class in C# or Java that represents a database connection. I imagine a lot of people. And this is fairly standard affair. It takes a connection string name, it looks up that name in the configuration, and it creates a connection. This is for some append-only database. I don't know what it is. It's only got a save function. And when it saves, it gives us a little message. Right? So we want to get rid of this, because we want to get rid of having to worry about this. Because if I misregister with that in collect the container, or this thing takes a thing of type string. How many times in a container it only works on the type, and it takes a string. How can I just register a string in the container? Don't want to do that. So we're going to solve it with functions, because this is a functional language, and I think that's super cool. So we're going to create a function called save value in the database, and this takes the connection that we're going to use to save a value in the database. So this takes connection value, we use that connection to save. So we've made that class sort of functional, I guess. We put something into a function, we're going to expect something out. So we're going to use a feature, I think another feature that a lot of functional programming languages have, definitely F# has, which is called partial application, which is where you take a function with multiple parameters, you pass into that function a few of the parameters, and you get back a function that takes the rest of the parameters, which is really useful because it means you can create functions that have some values already set. Very much like a closure, JavaScript closures, you use that sort of stuff all the time. Very similar to that. And so what we've done here is we've created a save value in my database, not anyone's database, and we've partially applied the connection that we care about with our connection. So we've got a function now that all it does is takes a value and it saves it in our database. That's super cool, right? There's no more infrastructure we have to worry about now. All we have is a type signature. So now when we want to do work, we're going to take our value in our familiar transform function. We're going to pass that value into our transform function. We pass the result of our transform into the save database, and everything's done. And this is, I think this is super readable. We're giving another bit of syntactic sugar. This little arrow thing means take the output of the thing above it and pass it into the input of the thing below it. So the value is getting passed into transform, and then the result of the transform is getting passed into the save database. Does that make sense? So that's super cool. Now, I'm guessing the next thing you're going to say is, that's cool, but the reason why we use dependency injection is not because it makes our life easier, it makes our life harder, but it makes things more testable, right? Because we can pass in mocks of the things that we care about into what we want to test. So this now, we're saying, my database connection, this seems like maybe we're not going to be able to test it. False, we can. So we're going to do it with more functions, because in functional programming, if there's a pattern, the answer is not a pattern, more functions. So what we're going to do is we're going to take our testable version of that, and we're going to pass in the function that saves it. How does that help? Well, it means that we can mock that's the actual save action and make our version of our transform thing, which is actually what we want to test, testable. Can anyone guess what save function might look like? Bit early, maybe 2 more beers and people will be shouting out. So we can test it with a mock version of that function. So a mock version of that function is our super duper testable save function, but we're going to pass in something that isn't using our database connection. So in this case, it's this function, this lambda, that takes the value and just passes it on. So it has the same type signature as the thing that our database does, so everything compiles fine, but we don't have to worry about the actual database connection. So when we do our test, I hope this works. So we need to open IDinLondon.inf. I think I've got this one. Cool. And then run the test. Because we're short on time, I missed one section out. So if we'd called this before, do you remember there was a bit of logging to say in the collection we would like just print a line to say we've saved this to the database. So when we run this, we get full true because our expected does equal our result, but we don't have any logging to say we've actually called the database because we've mocked it out. So we've got rid of our infrastructure code and it's still super testable. So DIs are rubbish. Right, next point. So make the compiler work for its money. It was free, none of us paid any money for it, but let's make it work harder. And one of the things I think is super cool about this in F#, units of calculation I think is only in F#. I'm not sure it's in many other functional languages. I can't see anyone shaking their head. I don't think it's anywhere else. But I'm going to use that to explain how you can make the compiler work a little bit harder. So here we have a few units of measure. So the way that they are is they describe like a unit for a calculation. So here we've got meters, which is like length, an area, which is a cube of a length, or meters, volume, square, which is a cube, area, which is a cube. We can new them up, essentially creating values using a literal here. These ones are decimals with m of those types of unit. And that means here we can have something here which returns width times height, which I'm saying is an area. And if I change that there, and hopefully you already know, do I have to build it? I have to build it. Build. That won't build. It failed because decimal error does not match the type, because this is supposed to be a square of those things, and now it's got a divide in it, so that doesn't work. So that's pretty cool. I'm going to gloss over that because we are running out of time, and now the compiler error is gone. So with these types, we can now do more interesting things with our domain code. So initially, we have an object here, which is our measurements, which just has primitives on it. Primitives are rubbish. We can put anything in there. Our height could be a number from any part of our application, which maps, which is the same type. We don't want that. So now we can create more interesting versions of that. So here we're using single case unions, really easy to express. A hand size is a decimal of area, which is cool, but it has to be of actual type hand size, which we can unbox. So what we're doing here is we're making the compiler work much harder, and also giving us some clues. So if we try and add something in there that mismatches one of those units of measurement we gave, or mismatches one of those sort of lightweight types, it will break. So we can add all this extra stuff into our type system to be able to explain the domain and make the compiler work harder. And that's also super cool. So now, there we go. So, that's enough of the good stuff. What's bad about it? FML functional. I don't have much time to go over this because, to be honest, I love it more than I hate it. But some points are, one of the points to work out for is vendor libraries. There are so many vendor libraries which have been built for many, many years on the basis of things that are incredibly object-oriented and incredibly class-oriented. One of the examples I'll give you here is Bouncy Castle. Hands up, anyone used Bouncy Castle in Java or C#? Did you like it? No. It's pretty horrible. It's super sort of imperative OO taken to some bizarre extreme. And if you try and interact with it with F# or any functional language, it is hell. It's horrible, and you end up writing all of that infrastructure code that we were talking about trying to get rid of just to be able to bridge that gap. And that's really horrible. I think I've got a couple of other examples, which I'll just stick on the screen while I'm moaning about them. Automapper, very common library within C#. Try and use it in F#, and it's painful. Elasticsearch looks really functional. Try and use it with F#. It's super painful. Bouncy Castle, string.mt, rubbish. ASP.NET. Also, the support, I don't understand why there isn't more support. If you want to get involved in an open source project, make ASP.NET and make Visual Studio and web work with F# nicer. There are templates out there, but they're always out of date and a bit rubbish. And it's just it's rubbish because you don't want to have to deal with this stuff. You want to be writing business code. And so I think interacting with those third-party vendor libraries and things like that is just more of a headache than is necessary than the sort of the boon you're going to get. So that's something to be wary of. Another thing to be wary of, I think, is something I call Uncle Ben code. I call it Uncle Ben not because of rice, but Uncle Ben because of Spider-Man, who says, what does Uncle Ben from Spider-Man say? With great power comes great responsibility. Or as I say, with great power comes great mess. So I have some code here. Can anyone tell me what this does? No, you can't. And ironically, I've said pretending everything is maths, and you will see a lot of examples of functional code from academics. It is very mathematical. It's not necessarily helpful for the next developer who comes to look at it, because they won't have any idea what you're talking about. And this code, particularly, I just wrote blindly. It is maths, incidentally. Probably should have done something that isn't. But it's completely unreadable. So why would you do that? Another thing is functional programming is particularly good with lists. They have lots of things built around manipulating lists, like closure. Basically, everything's a list. But you can easily forget sensible heuristics around algorithms. So here we've got stats for an array. We want to calculate the sum, the mean, and the mode. Now, all of these things should be an ON problem, right? You should be able to just iterate the list and you would get the values. But that's quite hard to do. And working out exactly how to fold that list in the right way to get all three at once might give you a headache on write code that looks like the maths we saw before. So people might write code that looks like this, which is where we're iterating the array a bazillion times, completely unnecessarily, because piping into sequence dot something is much easier. I've seen this code like this live, and it's rubbish. If a loop is better, write a loop. It's fine. But once again, functional languages don't often lead to be obvious about the solution to be able to do those things. It's quite easy to write code like this. And that's not excellent. So, my final point, which I think is kind of rounds it up, is the one about training. All of these lessons are maybe lessons that I could have learned before I started writing code, the ones that were good and the ones that were bad. Finding the time, finding the right people to talk to, and learning about the mistakes as well as their successes is hard. Finding the time to be able to learn. If you're already writing code in an object-oriented world and your boss is like, write code that makes me money, it's very hard to say, no, but I want to write code for 2 weeks that I don't know whether it will make you money. I want to learn how to do it better because I think it will be applied. It's really hard, really, really hard. I've run teams where I've wanted to get people more interested, and then there's been pressures, and I've been trying to do it myself. And that's really hard. And getting the training, getting the time is tough. Finding people that want to do it is tough. And what you don't want to do is go off on your own because you're super passionate, and then leave. I've said they're monkeys, that's harsh, behind, having no idea what's going on, and you're going, oh, it's just a monad, you don't know, you should be able to know, right? That's not okay. You need to be sympathetic about these things. So that's my rant over. I'm going to disappear into the hedges. So what I'm trying to say is, when doing this stuff, when adopting a functional language, and I think it's super, super cool for all the reasons that I said, you should definitely do it. But one, limit the language scope. Scala especially has got like a bazillion features. And when you're first introducing them to a team and you first want to get them trained up, don't create something that no one's going to understand. Limit the language scope. You can do a lot of really good work. I showed a lot of very simple, sort of basic features from F# there and how you can create some excellent, excellent code from it. So you don't need to jump in with all of the features straight away. So limit the language scope. Limit the blast radius. Write self-contained, cool things that people can understand and prove your point, because proving your point is the thing you're trying to do the most, because as soon as you've done that, your boss will give you the time to train everybody in using Elm everywhere. And introduce slowly, once again, make sure everyone's up to speed as you do it. Don't go off on one before people are sort of on board. Talk a lot and review a lot. This kind of occasion, I'm sure a lot of you guys work for companies that have like regular tech meetups and stuff like that. You can present at lunchtime and stuff, so definitely do that. That's super cool. And the final piece of advice I would say is when sort of building boring enterprise code is try and build libraries, not applications. Find something where a data translation makes a lot of sense. Prove its point. Don't go off and build some service that no one understands in Clojure when everyone else is using Java 6, because that's going to be tough for everybody and you're not going to prove your point. And all the people then that go have to look at your code will say, oh, we had a guy that did functional programming here once and it was awful, and I never want to see it ever again. So, don't let me put you off. Be careful. Functional programming is totally awesome and totally worth it. Final point from Homer, who says, yeah, I'm not going to change your lives. I'll still be the same loving parent I've always been. So don't let it change you too much, and always be a decent Boy Scout developer when you're approaching these sort of things if they're new to you. That's it. This is me. So that's my Twitter. and my email and stuff. Does anybody have any questions?
It was bang on 30 minutes.
Any questions? None at all? Awesome.
Oh,
I must have been. Oh, okay, go on.
Okay. Are there basically no reference types in F#?
No, there absolutely 100% are. Everything is still as it is in .NET, like a reference type, but they implement certain interfaces to be able to do the structural comparison and stuff like that. So yeah, if you construct a class, it's still got a reference. If you construct one of those records, it's still got a reference, but when you do that, like get hash code, who are you?
Yeah.
It's doing a structural comparison, which is just kind of like stuff that's built in into the IL. You don't have to sort of worry about it too much. And if you want to, you can make all those things mutable if you want to. And I think classes still compare by reference. Yeah, is that right? Yeah. So yeah. Like a mutable attribute. Is it? Yeah. Yeah. Was there one other question? There was a hand half. Okay, cool. Thank you.
excellent. Thank you very much. So we'll just have 5-10 minutes, swap over the speakers, use the loo, grab some more pizza and drinks. All the drinks, by the way, in the fridge, just please help yourself.
Cool, that was really good. It was good. It was just the right speed. Okay.